Well, we consider a question on inequalities, and the question of interest reads: solve the inequality, solve the inequality 3 into 2x minus 1 is greater than x plus 4. And this is 4 marks. That's 4 marks. Now, first thing what we need to do in order to solve that question is to square both sides, because this side here means modulus, strictly picking the positive sides. So that's what this side means. So first what I'll do is to square. The effect of squaring will ensure that both sides are absolute or positive. So here, if I square 3, I get 9. And if I square 2x minus 1, 2x minus 1 times 2x minus 1, that should give me this by this, 4x squared minus 2x, so it will be minus 4x plus 1. So 4x squared minus 4x plus 1 is greater than, then I square x plus 4. So x plus 4, x plus 4 should as well give me x squared, that's 4x plus 8x plus 16. So this then should imply that here I have greater than x squared plus 8x plus 16. So that is what I have. That is what I have. So I need to open up the bracket, open up this bracket, and then connect the like terms. So this will be, if I open up the bracket, I'll be having 36x squared minus 36x minus 36x plus 9 is greater than, now because of space allowed to write this here, x squared plus 8x plus 16. Now collecting like terms, this will have to cross, and then I get 35x squared, and then this will also cross. Being positive, if it crosses, it becomes negative, and that is negative 44x. So it's minus 44x. This should also cross, so it's going to be 9 minus 16. 9 minus 16 is plus 7. So I get here plus 7. It's greater than 0, because I've picked every other thing. I've picked everything from this end. Every other thing, everything that was on the other side, I've brought it this end, leaving me with 0. So that's where I am. So basically what I have is 35x squared minus 4x plus 7 is greater than 0. So the next thing is to factorize, because if you look at this question, it's quadratic. So we only have two options: either to solve using a quadratic formula, or if we can find two factors whose product should give me 35 times 7, and sum should give me negative 44. But looking at it, looks like 35 and 7 are both can both be divided by, okay, 7 can go into all, but not here. So we wish that perhaps we had 49. If we had 49, then we would have a situation where 7 goes into 7, it goes into 49 and also 35. But then we can tweak it. So that we say 35x squared minus 49x because that 49 is what we had wished to have for convenience, plus 5x plus 7 is greater than 0. Now, looking at this, we have just tweaked it, but the sense is not lost because this is this. Because if you consider this part, you realize that minus 49x plus 5x still gives you minus 44x. So there's little we are, okay, I've just changed the way I've rewritten it without losing the meaning. And I can then factorize. So here 7 can go in both. So I can say 7x outside. And then I have 5x minus 7 plus, actually minus, should be minus 1 into 5x minus 7 is greater than 0. It's greater than 0, like that. So I've found a way to express it. I've found a way to express it. And then this should then just imply that 7x minus 1 into 5x minus 7 is greater than 0. So it means that the whole function should be greater than 0. So even if we drew our curve, then we should be interested in those particular regions that are, because if the whole function is greater than 0, then we should be referring to those regions that are above the origin. So I'll sketch. So this should imply that it's either 7x minus 1 is greater than 0, or 5x minus 7 is greater than 0. So I have 7x, that should imply that 7x minus 1 is greater than 0, or 5x minus 7 is greater than 0. Therefore, x will be, in this case, x will be greater than, because 7x will be greater than 1. So x will be greater than 1 over 7, or x will be greater than, or x will be greater than, or x will be greater than, if this goes that end, it becomes 7 over 5 as such. So we have, let me just see again what we have. Yes. Yeah, because having this factorization, okay, having this here will end up for this, okay, that's also fine. But if I say minus, that's going to give minus 5, and yet I have plus 5 here. Well, it's going to give me plus 5. So in this case, what was x actually is greater than this. So then 7x So the mistake is here. Is this plus 7 or minus 7? Because if 16 is brought to this end, it's going to be minus 16 plus 25 plus 9. Minus 16 plus 9 is minus 7. So this is minus 7. This is minus 7. And if that is minus 7, then it means that this also becomes minus 7. And if that's the case, this becomes a plus. And so this is a plus. And this is a plus. And this becomes minus 1 over 7. So x now is greater than minus 1 over 7, or x is greater than 7 over 5. Yeah. That now makes sense. Now, what then we have is that we have these two values, but then we had seen that this is greater than 0. So perhaps we sketch, but looking at this, the coefficient of x squared, the sign of the coefficient of x squared, we know that we are dealing with a U-shaped curve. So it should be something that looks like this, being that it's U-shaped, something that looks like this. Oh, sorry, because I have a negative end, I should have given space. Yeah. Should have given space because there's a negative involved. So let me just use this and this. Yeah, maybe this, that. So this is x-axis, that's the y-axis. And we are told that at some point we have x. Strictly, we can interpret this already loosely. We can take it to be x is equal to minus 1 over 7 for purposes of drawing our curve, or x is equal to 7 over 5. Now, if I take that case, then I would imagine that 7 over 5 is somewhere there. And negative 7 over 1 over 7 would be this end. So let me just put it here. So it's negative 1 over 7. So I have those 2 points. But then my curve is U-shaped. So let's see. If it is U-shaped, I'm sketching, then it looks like that. It looks like this. That's what my curve is. That's what my curve looks like. And this function here is that. So it is, the function is 3 into 2x, 3 into 2x minus 1 is greater than x plus 4. Now that's this function. But realize that at this point it is greater than 0. The function is greater than 0. So what we are going to do is to take the points, the regions of this curve which are above. So for instance, it's this region. It's this region because it's above the x-axis. This is above the x-axis. The other region which is above the x-axis is this. So that's how it looks like. That's the solution to our question. And so what we say is, because the whole function is greater than 0, so portion above x-axis will be considered. And if that is the case, how then do we define that portion above? How do we define that portion above the x-axis? The portion can then be defined as, because this then should imply that we take a case where x is greater than 7 over 5. Because where that end. Or x is less than. Coming this end, it gets smaller. Going that end, it gets bigger. So x is less than negative 1 over 7. X is less than negative 1 over 7. And that wraps up the answer to our question. And so if that particular presentation was useful to you, then I urge you to subscribe so that you can continue getting more of such. So up to there, see you in my next video.